example 5, the big idea of this is what you have at any given moment is a combination of what you started with plus what you've accumulated since then. With example 5, we have a table here, and you'll see in each of these kinds of free response problems, a lot of times you'll see a graph, other times you'll see a table, other times you see an equation, or there might be some kind of verbal description, and you have to be able to go back and forth between all of those versions and understand them inside and out. So with this example, we have a one-day contest to name a new baby elephant. Aw, how cute. What name would you come up with for your baby elephant? Put that in your whisk. All right, zoo visitors, deposited entries, blah, blah, blah. You can read this. Great. Part A, use the data in the table to approximate the rate in hundreds of entries per hour. There's units. That's going to be important, so I'm underlining that. At which entries were being deposited at time t equals 6. So with this, we get back to that. Okay, good. So we're trying to approximate. So we're gonna, that's our squiggle. Okay, so we're gonna approximate the rate. So the rate of E of t, we're going to approximate that, and not just E of t either, at time t equals 6. So that'll be even more specific. E prime of 6, we're gonna approximate that. Now in our table, 6 falls in between 5 and 7, so we're going to use those values there. We can approximate this by doing 21 minus 13 over 7 minus 5. So the answer would be 4. You could also leave it as 21 minus 13 over 7 minus 5. And now, anytime we're doing word problems, if you are able to, you want to put units. Okay, so this is in 4. The units are hundreds of entries per hour. So you could either say 400 entries per hour or 400 entries per hour. There we go. You should use your units. All right, part B, use a trapezoidal sum. They're telling you to use a trapezoidal sum. So you need to show this with 4 subintervals. So if we take a look at our table, this difference is 2, this one's 3, this one's 2, this one's 1. So we can't really use any shortcuts here when we set up this trapezoidal sum. So to approximate the value of this, 1/8, 0 to 8, E of t dt. So we are approximating it by trapezoidal sum. I have that 1/8. All right, so then I have trapezoid 1/2. And my first height plus the bases, times the sum of the bases. And then my next height times the sum of the bases. And then my next height times the sum of the bases. Oh, I think I wrote the wrong part. Okay, so 3 times 4 plus 13. There we go. That's better. Plus 2 times 13 plus 21. Plus 1 times 21 plus 23. Oh, come on, pen. There we go. So that is our trapezoidal sum. If you want an approximation here, it would be about 10.687. Now it says, using correct units, explain the meaning of that in terms of the number of entries. Well, we know that this will give us the hundreds of entries over a certain amount of time, but what is that 1/8? Well, if you remember, that is our average value. So we would say that this can be represented as is, oh man, okay, is, be careful with how you word this, the average number of hundreds of entries. So remember, that's what our units are. Hundreds of entries in the box between, and we should say the times that we have. And t equals 0 here is noon and 8 p.m. There we go. So that's enough to answer the question. Let's keep going. Part C. At 8 p.m., they process it by the equation. So how many entries had not yet been processed by midnight? Well, we have 2,300 entries there at midnight. Okay, so we have 2,300 already, and we want to take away all the ones that they processed between 8 and noon. Since this is a calculator problem, I would use your calculator here, and you should get 16. So 23 minus 16, we get 7. And remember to put your units, 100 entries. Okay, it looks like we answered everything there. And then the next one, part D. According to the model from part C, what time were the entries being processed most quickly? So we're trying to maximize the P of t function. So if we're going to do that, we need to find the critical values. We need to find this, where the derivative of p would equal 0. Now, again, this is a calculator problem. So either use a graph and find that, okay, or use your solver. But either way, you should get t is about equal to 9 point, I'm going to write out a whole bunch of decimals here because I'm going to use it again. And t is also equal to this. So remember, a critical value, a maximum, can occur at either of these critical values or also at the endpoints. So I'm going to check the endpoints here. P of 8, P of 9.183, dot, dot, dot. All right, P of 10.816, dot, dot, dot. And also, I'm going to check my other endpoint of midnight. So when it's being processed most quickly, plug these in, I get 0, I get 8, and I have these numbers. And you don't have to write this many decimals, but I am. Okay, so now we have the numbers. Let's answer the question. The entries are processed most quickly. Oh, I forgot to write process. There we go. Processed most quickly at time t equals 12. All right, so we have all of the parts. So let me go back and tell you about the analysis. If in case you tried to do this by yourself, you'd want to know where you would stand. So the mean score for this in 2010 was 2.60 for A/B test takers. Out of the people who got a 9, only 0.5% of the total A/B test takers got a 9, all 9 points for this. On the other hand, there were 19.2% of the people who got 0 points for this. Okay, so just keep that in mind. As you're doing these kind of problems, they're meant to be challenging. So, part A, you get 1 point for the 400 entries per hour. Okay, part B, you get a point for showing that trapezoidal sum. You get a point for the value. Okay, and you also get a point for your explanation. Part C, you get a point just for writing this part. Okay, that integral. And then you get a point for the answer. So now we're up to 6. And so we have 3 left in the last one. Just for realizing that the critical values occur when the derivative is 0. 1 point. You get 1 point for having all of these values, and you also get 1 point for answering the question for a total of 9. Now we're going to spend some time in class working on these because the only way you get better is by practicing. So we'll continue to do that until you guys feel very confident going into these, and I know that you can do it. Now, tonight would be a good night to take 10 more minutes, maybe 15, and try some of the problems in your worksheet. Have a great